In this video, we are going to break down the 3 steps to sketch method to graph advanced tangent graphs. So these are your tangent equations that have shifts. Here's the general form, and you can see that it has a shift if it has a C term or a D term. And so note that this method, like I said, is for shifted tangent graphs, and it's going to build on our basic tangent graphs method. So if you haven't already checked out that video, go ahead and watch that and then watch this one, because you'll see that a lot of the foundational pieces will be the same, and we are really just adding shifts on top of that. All right, so here is the 3 steps to sketch method for shifted tangent graphs. In step 1, we'll find the essentials. In step 2, we'll plot the base pattern. And step 3 will be to shift, sketch, and repeat. Now, we will break these down in much more detail in just a moment. But before we do that, here's a quick tip that can help you do a little bit of prep on your equation that will just help you avoid a very common error. So my tip is to rewrite your equation to factor out b if you need to. So here's our basic equation, our general form. And if you factor out b, it looks a little funky in the general form, but the reason that you would do this is so that you can see c over b very clearly. That is the phase shift. And a lot of times if people have it in the form where it's just bx minus c, they'll incorrectly state that the phase shift is just c. So either, remember, when you find the phase shift, it should always be c divided by b, or take a quick second, factor out b, and then you can just look straight at your equation and know that you won't be tempted to say the wrong thing. Okay, so here's a quick example so that we can actually see what it would look like to factor out the b term. Okay, so we see 2 is b, it's the term in front of x, and so we're just going to factor that out. We'll have y equals tangent, we'll pull out a 2, and we'll be left with x minus pi over 4. And you can always double check yourself by just distributing that 2 back. So here we can see we'd have 2x and minus 2 pi over 4, which is the same thing as minus pi over 2. Okay, and again, the benefit here is that you can simply look at your equation and immediately see the phase shift. So looking here, you would be able to see, oh, pi over 4 is c over b. And so the phase shift is pi over 4. Or you would move your graph right pi over 4 units. Okay, so now let's dig into this method. Our first step is going to be finding the essential information. So this is really where we will analyze our equation, we'll get organized, we'll break everything down so that the actual graphing is relatively easy. So here's our equation with b factored out. And our first thing will be to analyze a, b, c, and d. So if you're thinking about function transformations in general, these will act as all of those function transformations that you've learned previously. So the vertical transformations will behave like all other vertical transformations, and same thing with the horizontal transformations. We just choose to deal with them a little bit differently. I will have a nice template at the end of this, and that will help even more break this down, and so that you have a nice order and can keep everything organized. All right, so starting off, we have our horizontal transformations b and c. So b will tell us how many cycles we have between 0 and pi. And remember, for tangent, we're different than sine and cosine. We should be between 0 and pi for everything that we're doing. Okay, for our period, we'll calculate that, pi divided by b. As we said before, c over b is the phase shift, and if you've factored out b from your equation, then you should be staring right at it. So right here. And of course, you would just have to make sure you look at the sign, and if it's minus, it'll be right. If it's plus, it'll be left. And more on that in the examples. Check the video description for some links to examples. And finally, our asymptotes. So these are vertical asymptotes, and we'll talk in detail about how to do this in just a minute. Note that there is a video, I'll put it in the links as well, that makes asymptotes really, really easy. And so it'll just break this down a little bit more and give a couple more examples so that you can feel really confident that you've found the equation that'll give you all of the asymptotes for your tangent graph. Okay, then we have our vertical transformations, A and D. So A is going to be your vertical stretch or compression. Note that if A is negative, our graph will be reflected vertically, so reflected over the x-axis. And D will be our vertical shift. So if we see +1, we'll move up 1. If we see -1, we'll move down 1. All right, once we have all that, we can choose scale labels. And so we do this really intentionally, especially for the horizontal labels. This is how we're going to count and label the tick marks. So for our horizontal axis, we will count taking the period and dividing it by 4. That's how we'll label our tick marks. And we do that really intentionally because in the next step, our base pattern will have 4 key points or pieces, and we want each of those to align with our horizontal tick marks. So we've designed it very intentionally. And of course, with these more advanced equations that have shifts, eventually we'll probably shift off of those. But it's a really nice place to start, and it allows you to really double check yourself and feel confident that you're on the right track. All right, for our vertical scale labels, we can usually just use one. That's typically what I like to do. And it allows for good comparison so that if you graph multiple tangent equations, you can see the difference in vertical stretch and compression, those points that are kind of the curve shaping points. And we'll get into that more in some examples. All right, so to find the asymptotes, it's very simple. From the original equation, you'll take all your horizontal transformations, which will be the inputs of the function. So we're specifically looking here, the inputs of the function, and you set those you set that expression equal to pi over 2 plus pi k. And we do that because that's the representation for the asymptotes of the parent graph y equals tangent x. Okay. Again, there is a link that will take you to the video on asymptotes made easy for tangent graphs. And it will explain this in a lot more detail, or when we work some of the examples for shifted tangent graphs, you'll see it as well. But this makes it really easy to find the equation for all the asymptotes of your graph. Basically, all you're doing is you're applying your horizontal transformations to the original asymptotes, which then puts them in the right place for your equation. One more thing, remember with this k is just an integer, and the reason we have k there is so that we can generate each asymptote in the graph, because of course it's a periodic function, or it repeats over and over again. So you'll have asymptote and then another asymptote in the next cycle, and then another asymptote in the next cycle. All right, so that's step 1. We've got a lot of information to get organized. Again, check out the template at the end of the video because I set it up in a way that makes everything flow really well. But I really wanted to break it down here in terms of horizontal versus vertical. Okay, so step 2 is to plot the base pattern. And note that this is going to be the graph without shifts. So we're really graphing what we would for the basic method, which is in the form A tangent BX. So you'll want to do this lightly or in a different color so that you know it's not the final graph. We will shift in the next step. All right, there's our equation, and here's our base pattern for tangent. It's 0, point, asymptote, point. Remember, 0 is just another name for x-intercept. And those points I like to think of in my head as curve shaping points. They really develop that tangent curve, that characteristic curve. Okay, so breaking those down a little bit more, we have our first 0 will be at the origin. Our point will happen at our first horizontal tick mark moving to the right of the origin, and its y-coordinate will be determined by A. The asymptote will happen at the second horizontal tick mark, and the final point will happen at the third horizontal tick mark with its y-coordinate the opposite of A. Okay, so that is a really good breakdown. We'll look at it in some examples. If your A is negative, your base graph is going to reflect over the x-axis. So you can still follow the template. Here, everything will work out exactly the same. Basically, instead of, I'll just do a rough sketch, instead of a tangent curve that has the characteristic shape, when A is negative, it reflects over the x-axis, so you end up with this lighter blue curve. Okay, that's all that's saying. Okay, so like I said, in this step, we're really graphing the base function y equals a tan bx, and we're going to apply the shift in step 3. Okay, so we lightly plotted our base pattern. Now we're ready to shift. All right, step 3 is to shift, sketch, and repeat. There's our equation. So we will apply our shifts, and we can usually, if we have both a phase shift and a vertical shift, working from the base pattern, you can apply both of those shifts at the same time. Okay, remember our phase shift is just C over B, so you'll move right or left, and your vertical shift is D, you'll move up or down. Then you'll sketch in your tangent curve, and finally you'll repeat that pattern for as many cycles as you need. So you can see a lot of the work is done up front in step 1, and then steps 2 and 3 are pretty simple once you've practiced it a couple of times. So now we have our template, and this will work to help guide you through the advanced 3 steps to sketch method for tangent graphs. So you can see in step 1, finding the essentials, we've broken it down into finding the base graph and the scale labels first. So we're using A and B, and this will be identical to the basic method. This will all be the stuff that you use for step 2, plotting that base pattern lightly as your starting point or as your intermediate graph. And then, still in step 1, you'll find the shifts, okay, which will help you in step 3, where you're actually shifting and sketching in your graph. I also like to use the asymptotes trick, and I'll usually do that as I'm finishing up step 1, gathering and analyzing all of my information. But I use that asymptotes made easy trick because I want to make sure that I have my asymptotes graphed in the right place. And a lot of times you really do need, or you're asked for, what's the equation of the asymptotes, or what are the asymptotes of the graph. And so it's nice to just go ahead and have that. Boost your confidence in your graph, and also you may need that information later. Okay, so without actually working through an example, I want to show you what this will look like. So we're not going to have any specific information, but let's assume we found all of our pieces in step 1. We identified our shifts, we found our asymptotes. Our base pattern for a tangent will look roughly like this for step 2. And remember, we will plot it lightly or in a different color than we'll use for our final graph. So we have a 0 at the origin. Let's just assume our first curve shaping point falls here. We'll have an asymptote at our second horizontal tick mark, and then we have our second curve shaping point down here in line with the third tick mark. And then we'd repeat, so we'd start again. Let's just put a point that'll help us close out our curve. Okay, so this would be an unshifted base pattern tangent graph. Okay, so let's just say that our shifts had been equal to right 1 horizontal grid unit and up 2. All you have to do is take your base pattern and shift them all right 1 and up 2. And this is just in general, just to show you what it'd look like. Right 1 and up 2. Okay, the asymptote, when we move it right 1, of course that changes it, but moving a vertical line up or down doesn't really change anything. All right, last points, right 1, up 2, right 1, up 2. Okay, so I'm going to make those really dark so we can see them clearly. We would sketch in that tangent curve. Okay, and that is one cycle of a tangent graph. Of course, you could repeat this pattern to get as many cycles as you needed. So of course, this graph continues over here, and we could work the pattern backwards. So the curve shaping point below, we'd have an asymptote here. We'd have an upper curve shaping point, what was an original 0, okay, another curve shaping point, and then the asymptote, and you can see we'd have another tangent curve right here. Okay, and finish that one out as well. And so this will get you a really nice shifted tangent graph. Like I said, tons of links in the video description. Check those out. Seeing this method in action with some examples, I'll post those really soon. And I think that really helps you out. So this method and graphing shifted tangent graphs in general takes a little bit of work, but once you've done it a couple of times, and since this method organizes everything in a really particular way, it'll really help you gain confidence and then become a pro at this in no time. All right, thanks for watching.